This video will introduce you to the algebraic process called factoring. Factoring is the opposite process to expanding. Specifically, this video will look at common factoring. So let's start with the example 4 times x plus 3. Okay. Now, if we were asked to expand this, then we know that we would multiply the 4 times the x to get 4x, and multiply the 4 times the 3 to get positive 12. So this is the expanded form, and the 4 times x plus 3 we call the factored form. So the process of factoring will take us in reverse from the 4x plus 12 back to the 4 times x plus 3. So that's the goal when we are factoring, is to do the reverse of what expanding looks like. Okay. So in order to factor, we're going to very quickly review what it means to find the greatest common factor of two numbers. So for example, if I wanted to find the greatest common factor, or GCF, of the numbers 4 and 12, then what I could do is list out the factors of 4. So these are numbers that divide evenly into 4 without any remainder. So those factors of 4 are 1, 2, and 4. And I would list out the factors of 12. And those factors would be 1, 2, 3, 4, 6, and 12. And if I'm looking for the greatest common factor, I look at these two lists and I look for the number that is in common that is the highest. So for these two lists, 4 would be the greatest common factor. So if my algebra question says to factor 4x plus 12, the first thing we're going to do is look for a common factor between these two terms. So between 4x and 12, or between the number 4 and 12, we know the greatest common factor is 4. So we are going to divide the two terms by 4 and write the 4 in front of the two terms that we get that are remaining. So 4x divided by 4 leaves me with x, and 12 divided by 4 leaves me with a positive 3. So the factored form would be 4 times x plus 3. Okay, let's look at another example. So this is 1, this is 2. So we want to factor 3x squared plus 15x minus 21. Okay. So again, we're going to look for the greatest common factor here. And here we have 3 terms. So we want the greatest common factor of 3, 15, and negative 21, or positive 21. So 3, 15, and 21. So the factors of 3 would be 1 and 3. The factors of 15 are 1, 3, 5, 15. And the factors of 21 are 1, 3, 7, and 21. And for the greatest common factor, we look for the number that's in common that is the highest, which in this case is 3. So the greatest common factor of 3, 15, and 21 is 3. So similar to what we did here, we're going to divide all 3 terms by that 3. So 3x squared divided by 3 leaves us with 1x squared. 15x divided by 3 is 5x. And negative 21 divided by 3 gives us negative 7. Okay. Now we can always check a factoring question by expanding, because factoring is the opposite process to expanding. So if I wanted to check that this was the correct factored form, I could expand this again. So if I expand, I get 3 times x squared is 3x squared. 3 times 5x is 15x. And 3 times -7 is -21. Another way to check factoring questions is you could use a graphing software like Desmos, for example, and graph both the expanded and the factored form as an equation or as a relation. So if I graph y equals 3x squared plus 15x minus 21, and I graph y equals 3 times x squared plus 5x minus 7, if those two make the exact same graph, then I know that they're equivalent. Okay, let's do a couple more examples. So we want to factor 2x squared minus 6x. So again, I'm going to look for the greatest common factor of 2 and 6. So the factors of 2 are just 1 and 2, and the factors of 6 are 1, 2, 3, and 6. So my greatest common factor is 2. Now, in this question, I also have a variable part that's in common with all of the terms in this polynomial. So each of the terms in the polynomial has at least an x. So x is a common factor between these two terms. So the greatest common factor of the coefficients, 2 and 6, is 2. But I also have a common factor between x squared and x. X squared, remember, x squared is really just x times x. So each of these two terms has at least an x contained in them. So if I divide each of these terms now by 2x, 2x squared divided by 2x, well, the 2 divided by 2 is a 1, and x squared divided by x leaves me with an x. -6 divided by 2 is a -3, and x divided by x gives me 1. So there won't be a variable piece here because the x divided by x gives just 1. So it would be -3 times 1 for that second term in the bracket. Okay? And again, this is our factored form because there is no common factor remaining between the terms x and -3, which is left in the bracket here. All right, let's do one more for common factoring. We want to factor -5x squared plus 25. Okay, so we're going to look for the GCF, or the greatest common factor, of 5 and 25. So factors of 5 are 1 and 5, and factors of 25 are 1, 5, and 25. So greatest common factor is 5. Okay. Now, when we have a polynomial like this where the first term has a -1 as a factor, or the first term is negative, often when we common factor, we will also take out that -1 as part of the common factor. So in this case, instead of using 5 as the greatest common factor, because that first term is negative, I'm going to use -5 as the common factor. Okay, now here we do not have a variable that's in common between both terms. So this term has an x squared, but this term does not have a variable piece at all, unlike in example 3. So -5 is what we're using for the whole common factor. And when we divide each term by -5, -5x squared divided by -5 gives us x squared, and 25 divided by -5 gives us -5. And again, there's no further common factor between x squared and -5, so we know that's a fully factored form. We can always check again by expanding to make sure that we get the expanded form back again.